Hi everyone, good evening. So wait, let's wait for 5 minutes. If anyone is joining, then we will start. Hi, good evening. Hello, am I audible?
Yeah, yeah.
Okay, so let's start today's session. Before we start, let me give you the clear picture uh, what we are going to learn today. So as I have already spoke with you guys, you don't have any experience about the plant 3D. So don't worry about that because whatever I have explained till now, we are going step by step. And this is the next step, which is related to pipe routing. So today, like we will be learning about the pipe routing and we will start from zero, and by the end of today you will be able to route pipes confidently in AutoCAD Plant 3D. Okay, so the today's topic will be covering about the piping, like what is the piping in Plant 3D, how pipes connects, pipe spec, pipe sizes, how to start routing. Also, the second step topic is the compass and shapes, which comes under this pipe routing section. Uh, Also about piping bends, the continuation grip, substitute parts, commands for pipe routing. what are the commands which we use, and also we will be taking one example for that. Okay, which will be like routing the pipe from pump nozzle to the vessel nozzle, like that, what we have created in our previous lecture. So, the today's topic is most exciting and I will say most important topics as a piping engineer when you are using the plant 3D. Today's topic is most important in all plant 3D because this is the thing you will be doing every single day on the job, whether you are working on a refinery, a chemical plant, a power plant. It means it does not matter what process, what plant you are working. So pipe routing is at the heart of everything in plant ready. Okay, if you're using the plant ready in your job. So now I know many of you are thinking, yeah, we don't have knowledge about this. We are not sure where to start. So that is completely okay. So that is why I am uh, here, and whatever experience I have gained by using the this software with this software, uh, I will be teaching you about that, those all the things which are related to pipe routing. So it's okay if you have zero knowledge, and today you will be also start that journey to routing the pipe in plant ready. So I want to ask you a question. Does anyone know what is a pipe in real life? Anyone can give the answer?
Yeah,
Means what is a
pipe
yeah?
pipe is an element that transfer fluid one place to another place.
Okay, yeah. This is also good. It is a very it is also good answer. But in real life, if we also can talk about the pipe, a pipe is hollow cylindrical tube that carries fluid like water, oil, gas, chemical. In process plant, these pipes connect different equipment, pumps, vessel, heat exchanger, column. The path that pipe takes from one equipment to another, that is called a pipe route. Pipe is the hollow cylindrical tube, and the route which is take is called a pipe route. And when we create this path in 3D model using the plant 3D, we call it pipe routing. Okay. So let's open the plant 3D. First, I will share my screen. Okay. My screen is visible to you, right? You can see my screen. Hello.
Yeah,
Now let's go open the plant 3D. So I search here the plant 3D and it will open. This is the 2026 version. So I have uh, 2026 version. If you have different version, you can open with me. So we can discuss and also do some practice with me. That would be good. Right? So this is our project which we have created. So first of all, I have explained all these interface, how to create the project and all those things. So now let's before starting pipe routing, let's know about the piping. Like what is the piping? what exactly is a piping in AutoCAD Plan 3D. So now you can see the software is open in front of us. This is the Plan 3D 2026. Now, when we talk about the piping in this software, we are not just talking about the single line, we are talking about a complete system. The pipe segments, the fittings like elbow, T, reducer, the flanges, the gasket, the bolts, everything together is called a piping system. In Plan 3D, piping is a intelligent. What do I mean by intelligent? I mean when you place a pipe, the software knows its size, its material, its specification. When you change the direction, it automatically puts an elbow. When you make a branch, it puts the T. You do not have to draw these fittings separately. The software handles it for you. That is the beauty of Plan Ready. So before doing a piping, you should have a understanding of pipe specification, which we call in Plant 3D pipe spec. It is very important if you can know about the what is a pipe specification. If you have done your fundamental classes, if you have learned about the PMS document, like piping material specification document, those specification which has been created are added in specs by spec. From that we can so whatever specification like material dimension, um material standard, dimension standard, size, all those things we mention in PMS, right? So those all the things will be added in pipe spec. Before we start pipe routing, I want to explain one very important concept, the pipe spec. This is something that confuse many beginners. So please pay attention. Okay. Now I will create one file for the piping here. So I will be creating new drawing. We have a project number, drawing category is PIP, which is piping, right? And drawing number is 001. Drawing description, like whatever you want to give, area, B, and revision 00. Okay. So this is the file which we will be using for our pipe routing. Okay. So I will be changing the visual style by using the VS command, and I will be putting the 2D wireframe here. So my dynamic input is off, so that's why the command is only showing here. But if my dynamic input is on, then I will type the command that will show on screen. Before that, I will on the options of model view and layout view, which is in display setting. Okay. So in the real life, pipe is not just a pipe. It has a nominal diameter, like size, a wall thickness, a material like carbon steel, stainless steel, or etc. Uh, a pressure rating, how much pressure it can handle, a temperature rating. In process plan, the engineering team creates a document called a piping material specification, or simply the pipe spec, which defines what kind of pipe, elbows, flanges, etc. to use, etc. to use uh, for a particular service. So in AutoCAD Plan Ready, this pipe spec is loaded into software. So when you route a pipe, you select the specs first, and then the software only allows you to use fittings that are approved in that spec. For example, if the spec says use 90-degree long radius elbow, it will not allow you to use short radius elbow if that short radius elbow has been not added in pipe spec. Okay. So like for real life in example, think of it like a menu in a restaurant. The pipe spec is menu. You can only order what is on the menu. You cannot ask for something that is not listed. The pipe spec is your menu for the piping system. So there are like how to first of all the question is how to start pipe routing. So there are five ways you can start the pipe routing. So the now in plant ready you can start routing a pipe in five different ways. So let me show you one by one. So you first way is using the ribbon, most common method for the beginners. So like you can see in the ribbon home tab the part insertion. So you will see this is a toolbar area with the tabs and buttons. Click on the home tab here, and in the home tab you will see the panel called part insertion. Inside that panel you will see the button root pipe. This is your main button for the routing the pipe. So if I click on root pipe, I can route the pipe whatever size has been given here. I can route the pipe of that size in 3D. So it will show you the pipe. Okay. So now this is the first way, and the second way using the command line. So for the command line, you can type the you can type on command bar your command line, and you can type command like plant. You can write it down somewhere, or we have already recording, so I think you will not need that. But if you want to read, write it down, you can write it down. So there is command like plant pipe add. So if I type that command pipe plant, it will show me these all the commands plant for the plant. Oh, so I am adding the pipe here. So I will click here, and just by clicking I can add the pipe. Okay. Also there is third way. If you have already routed the pipe. So this is our pipe which has been already routed. This one is also. So now if you click on this pipe, like if you select this pipe here, you will see the some colored arrow like handles, like this plus sign is there. This is a plus sign. This is the plus sign. So these are called grips. Okay. So these are the continuation grips. So click on it. Like if I click on plus, it will continue route the pipe, but for that, you have to already routed one pipe, which has been you will be continue from that pipe. So now you can see I have added the continuation pipe, and I have like changed the length of this single pipe here. Okay, so this is automatically connected. So for the fourth way is the spec viewer using the spec viewer, which is this tool palette on the right side. So so sorry. Um, So this is the panel which is called a specware. This is show you all the piping component available in your current pipe spec, which is we have selected SS150. So in that, whatever pipes has been there, you can drag and drop the pipe from here, or you can click and click on that pipe, and you can draw the pipe. Okay. Sorry. The part which I have shown you, so this is the tool palette, which is the fifth way. Uh, you will be not able to drag and drop. But if you see here in the part insertion, On the right side, this is a spec viewer. If you click on spec viewer, all the parts which are under this spec and what size range has been for that part you can see. And if you drag, should work. So if I click, or maybe no, not drag and drop, sorry. Yeah. Here in pipe, I have different sizes available, and I want to add a DN300 pipe here. And if I select that size, and I can insert in model, and now you can see I can insert that pipe. So if I go to the properties of this pipe, you can see the size has been changed, which I have selected a 500 here. So this is how you can add a new components, new by using you can add the pipes by using these all the five ways. You can try if your plant ready is open, and if you get any doubt, let me know. I will tell you again about that. Okay. So now we learn about the uh, how to add a pipe by
Actually,
using this.
while routing the pipe X and
Yeah,
Y direction, how can we
yeah.
change the plane to Z direction?
Hello.
Yeah,
Yeah.
while drawing the line route.
For the changing the plane. That is, I just show you how to take the pipe by different five ways. So we will be learning about all the things like planes and all the things. But I want to explain you one by one from the basic. First is the how to take the pipe, right? So after that, I will tell you. Not your question is right, but this is not the correct time to tell you about the plane. I will tell you in this session, in this session, but let's wait for some time. Okay.
Okay, okay. Then
Hello.
once
Yeah.
again explain about the second and third ways of
Yeah.
pipe.
Okay. Second and third, like using the continuation is third way, which I have told you. And the second way is a command, which is plant pipe add. This is the command which you can use, and it will add the pipe. Okay.
Okay,
Yeah. Now let's move forward. So before routing any pipe in model, so you need to setting up before routing some like choosing the pipe size and the pipe spec. So what pipe spec we will be using, what size we will be routing the pipe. It will be given in a PNID. So now we are going to actually start a routing. But before you click root pipe, you need to decide two things. Number one, what is the pipe of size of pipe, and number two, what is the pipe spec. So let me give you the example. Suppose we are working on a water line. The engineering team has specified pipe size 4 inches, and a pipe spec is A1. So this is a sample spec name. You can your actual project will have its own specs name. So in software, when you click root pipe at the bottom, you will see the command line saying specify start point or size, specification, stubin, elevation, routing option. So if I uh, so to set size, like if you want to set the size, you need to type S and then press enter. The command line will ask you the nominal size. Type your size, for example 4 inches for 4 inches, and press enter. To set spec, type SP and press enter. The command line will ask you piping specification. Type your spec name, for example A1, and press enter. So let me show you this step also. Now there is actually two ways, but I will show you what I have told you right now. Now I have taken the option of root pipe. So you can see on command bar, it is asking me, giving me five options like routing offset, elevation, stub-in, specification, size. So now I am taking the size, and it is asking me for the size, which I am taking a 250. Okay, now enter. Now I need to specify the specification. So I will take the SP enter, and this is a SS150, which I will be using the spec as a my spec. So now enter, and I can if I want to give the elevation or routing offset, I can give those also. But I'm explaining just the two options right now to you. So now I can route the pipe of DN250 here. You can see the size of this pipe is a 250 and spec is a SS to 150. So this is how you can give the specs, select the sizes and spec. So also you can see the change the current pipe size and spec in from the status bar at the bottom of screen, like here in the column, or you can see that in your um, oh, if I, so you can see that here also in part insertion. Okay, so whenever you are changing the sizes and spec, check here in the spec part insertion, which is this is a spec viewer, uh, and this is a size, so pipe size selector, and this is a spec selector. Now, as you ask me about the plane, so we will be understanding about the routing plane like X, Y, Z concept. So now this is another concept. So beginner find confusing in routing plane. So let me explain it simply. When you route a pipe, you are working in 3D space. This 3D space has a three dimension: X like left or right, Y front or back, and Z up and down. When you route a pipe, you route a pipe on a plane, a flat surface in 3D. Okay. By default, when you start routing, you are on a X and Y plane. This means you can go left, right, forward, backward, but not up or down. If you want to go up or down, you need to either change the routing plane or set an elevation. In AutoCAD Plan 3D, you can change the routing plane by pressing Control. Like I am routing the pipe here. Like I have routed one pipe. Now I want to uh, change the plane. Okay. So click Control plus right click on the drawing area. So you can see it has changed the plane. The software will toggle between X and Y coordinate, but you can see I am changing the plane by clicking on Control and right click of your mouse. So you can try this also. And one more thing, I will be change the view here. Like this is the 3D view, and you can see I am routing the pipe in all the direction here. But if you want to choose the plane, if it is not changing the side plane here, you can do one more thing. You can control right, you will be able to change the plane, right? Whatever direction you want. Or you can click simply P during your routing. So it will be changing the plane. Now let's see this pipe in 3D. You can see this is how this pipe has been routed. So to change the plane, you need to select the click P at the time of doing the routing. Or if you want to, like you are working in X and Y coordinate only, and you want to change the plane, you can do change the elevation, or you can select the uh, control and right click on your mouse and give the elevation. Now you can see it has routed the pipe on that Z direction without I don't need to go on the like 3D view for that. It is automatically changing the plane. Also in 3D view, I want to route the pipe here. Now it is showing all the planes. But if you want to say change a specific plane, you can change. Okay. So for a real example, imagine you are routing a water pipe in plant. The pipe starts at the pump at the ground level, goes horizontally to vessel, then goes vertically to connect to the nozzle. So on top of vessel, the horizontal part is on X and Y plane, right? The vertical part requires you to either change plane or set a new elevation. So Plant 3D handles this automatically when you set the elevation. As I have given the elevation, okay. So I will show you in 3D one more thing. I'm routing the pipe here, right? And I want to give the elevation. So I can give the elevation like 25,000. So it will automatically route the pipe on the elevation of that. So if I check ID here, you can see the end of the pipe is on the 25,000. Okay. So if you have a already elevation for that, you can give the elevation.
Why
Yeah.
this pipe route is in different color? Like so, sometimes comes in blue
Actually,
color.
yeah, I am using the different sizes. It is given in Plant 3D for different sizes. They are using it is in layer which has been created in project setup. I will tell you about that also. Actually, at the time of teaching the PNID, I have shown you that whenever you are using the different line sizes, according to line sizes, it is taking that colors. So now let me explain you that again. Spec update setting, no, plant ready class setting, and here, sorry, this layer and color setting you are saying showing here in project
Mm-hmm.
setup. Yeah, for whatever sizes you are taking different sizes, for those all different sizes, they have given the different colors. Like similar colors are also there, but not all the pipes are in same color. So you can assign different option here also. Like you don't want to use the layer by sizes, you want to assign those layers by like line number tag, and the assign color by spec. So you can change, it will show you the colors by spec, the spec you are using. Like we are using the SS150, so all the pipes which we are we will be routing under that spec are showing in a yellow color.
Okay, is
Okay,
this default or we can reset
we can
according
change,
to
we
the
can change, we can change. Right, like whatever you want, you can change according to your preference also. So
mm,
let me show you that option also here. Like I want to add a new here. You can add new option like automatic schemes has been given. This is the default which has been provided. In default, these are all the options. But if you see, all the options are already there, like material, manufacturer, long description, short description. All these options has been already given. So there are, I think, not much more options available to add, because all the cover up in this part. So according to that, like if you have a spec, nominal diameter, status, insulation, tracing type, insulation type, service, on service base you can give the colors. You can see
okay.
there are different services, and for all this different services there are different color. So mainly if you are, I will suggest one thing: try to use this according to services when you are working in process plant, because we have different colors given in PNID for different services. So this is
No,
the
normally,
better.
yeah,
Yeah,
correct. Because normally in the project spec, no, so they have some their own color coding for the
yeah,
pipes.
yeah.
So
So if you
apart
have,
from
yeah, if you have
yeah,
you can change that color by clicking here. You can take whatever color
mm-hmm.
you want. Yeah, this is already a option given. So if you want to change the color in different, you can change. So the it is very easy to choose the color according to your requirement. Okay.
Yes, yes, yeah. Please,
Okay.
please.
Yeah. Now let's. So now we learn about the how to change plane like X and Y. There are two options like control and right click of your mouse, and the second option is you can type P and you can change the elevation or change the plane. P means plane. So
Actually,
by using,
while clicking control and right click, some options are opening instead of changing the
yeah.
plane.
No, no, no. There those some options are like if I click Control P here, you can see it is changing the plane. It is showing me to route the pipe on Z elevation. So there are options like pipe fitting, size, specification, plane. So I have already changed the plane by clicking on Control P. So if I want to again change the plane, I will click P and it will change the plane. You can see. So, what you can do, you if you want to change the plane on like Z elevation. Now I have given the elevation like 25,000. Okay. So now again I want to change the plane because it is only routing the pipe in Z direction here. Now I will click again P and enter, and you can see it is changing the plane to X and Z coordinate. So this is how you can change the plane. Means so if you have done the 2D pipe routing, okay. So in that 2D pipe routing, if you have seen that you are running the pipe, but you will be showing the pipe is going above, like the symbol will be 2D symbol will be there, right? So by in 3D, you can route the pipe in 2D, but you can change the elevation also by changing this plane option. Okay, did you understand the point, or just
Yeah,
a
yeah, I'm
moment?
trying, but same like that only different. Actually, while Uh,
Or
from the
I will tell you one more simple option here. Don't get confused. If you can do the practice of this, it will easy to understand. Route the pipe, right? And you want to change the plane. Do it in 3D. Now click P and enter. You will be able to change the plane. Hello?
yeah, yeah. Okay.
What happened to my screen here? Just a moment. What some just a moment. I think my screen Plant 3D has been closed automatically. I'm trying to reopen. Okay. Sorry, actually the software closed, so all the things which we have added are gone. But now you understand how you can change the plane, right? So if sometimes it is difficult to route the pipe in 2D and changing the plane, it is difficult to understand. You can without using this control P option, you can do the routing. Like, I will take the S5000 and control. So this is adding the pipe in wrong direction actually. So this is the problem with the control this option. So now this is the correct one, right? So what mainly whenever you are adding in 2D the elevation, it gets difficult to add what if it is going down or if it is going up. You will be not able to understand that easily. So I will say one thing: try to route the pipe in 3D like this. And if you want to change the plane, just click P, and you will be able to change the plane. Okay. So this is how we can change the plane of our piping route. Now, let's move forward with the thing which we will be learning is connecting pipe to the equipment nozzles, right? Because the equipment nozzles are the things which we will be connecting our piping. So first of all, I will do one more thing. Whatever equipment we have created in our previous class, I will use those equipments as a XRF, right? So I have added XRF means I have added external reference, uh, o- the equipment which we created to use as a route the piping. So from this equipment, I will be routing my piping. So uh, this is the one of the most important thing you will be do in a connect a pipe to equipment nozzle. A nozzle is the opening and equipment. The connection point, for example, a pump has a suction nozzle and discharge nozzle. A vessel has a inlet and outlet nozzles, right? So when you route a pipe and want to connect it to nozzle, you need to use a node object snap. Let me show you when routing in active, and you move your cursor and near a nozzle. Like I'm taking the pipe here and I'm like going near to this nozzle here. My cursor is near to nozzle, and right, if you it is not showing on your nozzle like this. If your snap point is off, it will not show you that node point. But for that, you can do one thing, like you can click shift and right click your mouse, and you will get those all the snap points, like node, insert, nearest, node, all these points you can see, and just click on the node point, and it will select the node point only, and you can route your pipe. It will like pipe will connect perfectly to the nozzle. So the software also automatically adds the connection, like hardware connection, flanges, gasket, bolts, based on a pipe spec. Whatever details has been added in pipe spec, those you can, it will take automatically as a piping group. Okay, so this is how we can add a new pipe to the nozzle. So nozzle, equipment nozzle, we can connect the pipe to the equipment nozzle like this. And also I want to again add a pipe. I will select this pipe and again shift and go to the node point, and now it is showing me the connection is not possible because of the sizes. So now I have added that again. So so I have demonstrated you the how to connect the pipe to the equipment nozzle. If you have created the equipment in our previous classes session, or after that, you can use that equipment as a reference. For the adding to the reference, you just need to select uh, right click on file which you want to reference in this file. If you have used the AutoCAD, you should have the knowledge about the external reference, how to add the external reference. External reference means the file which we will be using as a reference. It is not in that file. It is created in different file. But for the reference, we need that file in this model. And Plant 3D, there is one more thing. If you are using the reference file, and that reference file, you can like it will connect if it is created in plant ready like this equipment, so it will connect the pipe and nozzle automatically. And if your model has been created in the AutoCAD 3D modeling, or in different software, or it is a step file, so you can use that. You will be not able to use that as you will be able to use, sorry, but that will not connect your pipe correctly to your nozzle. Okay, means you need to you will be going to select the node point, but it will not show you the node point. Okay, now let me tell you one more thing about the piping. Sometimes what engineers do, like piping engineers, sometimes they draw a pipe path using a simple AutoCAD line. Like I am drawing one line here, which will be like this. I'm not giving any dimension here, but for reference, I am just drawing one line. So this is my line. Okay, single line which I have drawn. So this is called a center line. It is like a rough sketch or of where the pipe should go. Later, this center line can convert into actual with fittings. And whatever lines I have drawn here, like this line, this is my routing, for example. Uh, so I can convert this line in a pipe pipe routing by and in Plant 3D, you can do this using the convert center line option. You draw a polyline in AutoCAD, just a regular line, then select it and use the Plant 3D command to convert it into the pipe. The software will follow the path of the center line and place the pipe and fittings accordingly. So this is very useful when you have a concept pipe route and you want to plan it first, like before doing the actual 3D routing. So it is it will be like take less time to convert. So let me show you how you can do that. Now for that we have a option here, line to pipe. So just select the line, whole line which you have drawn, and click line to pipe. Now you can see it has converted that all the line into pipe route. And the whatever size we have selected here, that has been taken as a size of pipe. So if that size of pipe was different, like it was, I will show you the option. What's the,
Sometimes, s-
yeah,
sometimes when we connect from the equipment, so when we
yeah,
directly route the pipe, so
yeah,
there is a one error like the
yeah.
auto flange is not.
I will show you. Not metric and imperial connection is not possible, right?
Yes, yeah, some kind of error.
Yeah, sometimes. This option this is error this error comes when like I will show you when we created our equipment, right, and
Mhm.
added the nozzle to that equipment. I will open the equipment file here, and I'm going to add one more nozzle here, and that nozzle, when we selected the size, is it in a metric or a imperial, like it is in a inches or or it is in a metric, means this DN sizes. And also when
Mhm.
you have selected the unit, you if you are selected a inches, and it will show you class of 150, 300, 400, 600, 900, 1500 and 2500. But if you have selected the mm, and it will show you the classes of PN16, PN25, PN14 flanges, and you have
Mhm.
selected this. So that flange which is PN16, which you have used for your nozzle, if it is a PN16, then that part which you have used, it should be in a now you can see this flange here is a 150 class. If you see the description here, I have shown in my cursor is there on that flange.
Mm,
But if I select that nozzle class is PN16 and select the flange
mm,
and close, and this nozzle has been added, and if I click plus, then it will show you me this error because my flange in spec is class 150 and the nozzle of this flange. That's why I explained you in the starting of this session that whatever we are added in our pipe spec, the nozzle which we are using in our plant ready should match, like classes or sizes. Those are sizes are in metric or inches. Those all the things matters when you are connecting your flanges, because if you have learned in your fundamental classes, you will be not able to route the like the different classes flanges, right? If my nozzle flange class is 300 and I'm trying to connect my class 150 flange to that flange actual, it would be not possible, right, in real life if I go, because my class 150 flange and class 300 flange both has a different OD, right? And the PCD of those flanges are also different, so we will be not able to connect those flanges. So this is the same scenario which has been given in plant 3D also.
yeah, yeah, understood. Please proceed.
Yeah. So this is the part which you should always remember whenever you are doing the piping. And if you get this type of error when you after selecting the correct classes also, because sometimes we get this kind of error. I will tell you in our next coming session how to resolve that issue, because that is the important part also. But like in today's session, I will be not able to explain you that part, because that is completely different parts which comes in the like 3D spec creation, like plant 3D spec creation and catalog. So I will explain that part in our coming session, which can be our tomorrow's session if we finish this pipe routings all the options today. So I will explain you about that tomorrow. Okay. Hello.
Yes, yes. Good.
Okay. Okay. So should we move forward?
Yes, please.
Okay. So the next option which we will be learning about is the compass and the snaps. So, like I will explain you what about the compass and the snaps. What is the compass? All right. So, if generally if you hear the word like compass, so what you get in your mind? So, I will explain. The compass is the most helpful tool in pipe routing. Okay. So we have talked about the piping basics. Now let's talk about the compass. This is something unique to AutoCAD Plan 3D. You will not find this in regular AutoCAD. The once you understand the compass, pipe routing becomes so much easier. So what is a compass? When you are in the middle of routing a pipe, and you have a specified a first point and the software says specify the next point. So you will see a circular tool appear on your screen around your cursor. This circle has a tick marks on it like a clock. On if you see on the clock is 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock, right? 10 o'clock. So same here in the circular tool, these cursors, these ticks are marks on it like a this is the compass. So let me show you what is the compass. This is the compass option which we have. This is off right now. Okay. So before on like using this option, I have one more point to explain. The compass has helped you to route the pipe at a precise angle. When you move your mouse, the pipe direction snaps to the tick marks on the compass. So instead of routing at some random angle, like random angle means I will say 37 degrees. So it will not show that angle. It snaps to the 30 degrees or 45 degrees or 90 degrees. Whatever angle set are set on your compass. So why compass is important? Let me give you a practical reason. In real life piping design, pipe should always be routed at a standard angle, like 0 degree straight, 90 degrees right angle, 45 degrees diagonal. You almost never route a pipe at a odd angle like 37 degrees or 63 degrees or 49 degrees because fittings do not come in those angles. Elbows come in 45 degrees and 90 degrees standard angles, right? So the compass, by snapping to the standard angle, ensures that you route the pipe correctly and that the software can add the correct fitting like a 90 degree when you change the direction. For a real example, think of compass like a protector on your drawing board. So for what you do by using the protector, you give the angle, right? So remember in school, we use a protector to measure and draw angles. The compass in Plant 3D is like a digital protector that snaps your pipe to the standard angle automatically. So now let's go do a compass setting. How to control the compass step by steps options which has been there. Now look at your we are in a home tab. In home tab, you will find a panel called compass. This is the compass which has been given after the ortho views, before the elevation and routing, and after the ortho views. Right? So inside this panel, you have some options like toggle options. This is a toggle compass. So toggle snaps on or off. This turns the angle snapping on or off. When it is on, your pipe direction snaps to the tick marks on the compass. When it is off, you can route at any free angle. Uh, so if you are beginner, keep it on always, right? Like this. And the second option is snap increment angle setting. So snap increment, if you see, this is the tick mark and this is the toggle snap option and this is the toggle tolerance. Okay. So if you have seen the snap increment option, which has been given the 15 degree here, if you click on drop down menu, you have different angle given. So this is the tick mark for a increment, or this is the snap for the increments. Okay, so you can so the uh, snap increment angle setting will be default. It is usually 15 degrees. So this means the compass has the tick marks on at 0, 15, 30, 45, 60, 75, 90 degrees, or 90. After 90 degrees are there different angles you can give there, those also. Okay. So you can change this. For example, if you set it to the 45 degrees, I will select the 45 degree here. So you can change this. Uh, you will only be able to route a pipe on 0 degree, 45 degree, and 90 degree. This is the safest setting for most work. And you can make there is a third is compass size. This is the snap increments. So you can make the compass bigger or smaller on screen. If your model has many pipes close together, a smaller compass is better. If you are working on a large open area, a bigger compass is easier to see. So I will route one pipe here with the compass is on. Now you can see it is showing me the options of the compass, which my pipe routing is only going on 90 degree because my option is on. But if you see if my eye off my ortho option, you can see the increment is showing in a 15 degrees. Yeah, you can see it is not showing the odd angle like different because my snap increment has been here is a 15. But if I take that 15 45 degree, now you can see it will only show me the option of 45 degree. Now I have routed already pipe on this direction. I can route the pipe. So this is very useful as a beginner when you are routing your pipe. So if I change the plane here, or I click Control P, you can see it is showing me the compass on the above direction. So this is mostly you can use whenever you are using the compass at the start as a beginner. You will be it will be very useful to you. Okay. So try to do the step which I have done and give the increment according to you, whatever angle. You can try by giving the now I'm resetting and I'm giving the 23-degree angle here. So whenever I will route the pipe, if my F8 option is off, sorry, it is on, but if it is on, you will be able to see the angle of 23 degrees. No, because we don't have a fitting of 23 degrees, but it will show me 15-degree angle. Okay, so this is only showing me 45-degree option. So you can on and off these options also. Like I want to off this, yeah, I want to set it on a 15-degree only. So you can change that, right? And now let's move to the advanced compass feature, which is a tolerance, which I have explained these three options to you. Now we are going to the advanced part, which is the tolerance angle. Now here is an advanced feature, the tolerance angle. This is very useful in real projects. Let me explain. Sometimes due to equipment positioning, uh, a pipe needs to be routed at almost but not exactly 90 degrees. Maybe it is 91 degrees. Normally, the compass would not allow this because it snaps to 90 degrees. But if you turn off the tolerance angle, you can specify a small tolerance, says 2 degrees. Now the software will allow you to use the 90-degree elbow even when the actual angle is between 88 and 92 degrees. Means if you understand the tolerance, what is tolerance means. So you can get the higher and lower, plus and minus tolerance. So it adjusts the fitting slightly to make the connection work, right? So to turn this on in the compass panel, go on the ribbon and look for so this is the tolerance angle option. By default it is off, so click turn it on and you can set your tolerance value. So if you want to change the tolerance, like you can see here it is given the some tolerance already, which is I will give 2 degree. Now you can see it has given me. Now I will route one simple pipe because we have already routed a complex structure. Okay, yeah. Now this is my compass. It is showing me 15 degrees here. But if I want to 45-degree and this is a 45-degree, okay. So because my tolerance option is on, now you can see it is showing me some options like this is the angle which is not the 90-degree, but I can still route my pipe on that angle because of the tolerance we have given. Here I'm moving my cursor little bit. You can see it is showing me 90-degree, but that 90-degree is not 90-degree here. That is something different. So try to set your angle. Also, there should be one more option here. This is my tolerance snap increment, which you can increase by 1 degree, 2 degrees. And now I have given the 1 degree here. And actually it can be a different, but it will draw my pipe on that angle. And it will show me the fitting, which will be so it gives you some clearance to route your pipe. Like in 90 degree is not possible, but you want to show the 90-degree elbow there. So it will give you that clearance to route your pipe. So this is also very useful to route the pipe like that. So now let's move to the object snap, which we shown like a node point we have seen. So the object snap, you might know about the object snap from basic AutoCAD. Also, they let you snap to different points on objects like end points, midpoint, center points, etc. In plant 3D routing, pipe in plant 3D pipe routing, object snap work the same way, but are even more critical here. So the most four important object snap for pipe routing are node point, connecting like when you can use these when connecting to equipment nozzles. And how to use, you can click shift plus right click on your mouse and select the node, and now move cursor over nozzle and click. So left click, so it will take the node point automatically. And the second snap point is end point. So whenever you are connecting end to end with another pipe, so you can do one more thing. For using the snap object, you can on your F3 here in the snap points. You can see these are the snap cursors, 2D and 3D. If I on this and here in this snap points, if I want what options I want to on, I can on, like I want to node point, I want end point. Also I want like a perpendicular or midpoint also I want to like on, and also near, perpendicular and near. So these are the five options which are on. Now if I want to route the pipe, like I'm taking pipe here and it is taking the endpoint automatically, right? And the third is the perpendicular, like whenever you are connecting to pipe at a right angle, like you want to take a branch from that pipe. Like this is a pipe where I want to take the branch of different pipe. So what I will do, I will select the perpendicular option here, and that would connect the pipe automatically. So this is the pipe to pipe connection. It is not the T or reducer, because in our specs, piping specification in branch table, it has given that connection of a stub-in. Okay. And the fourth is a near point. So whenever you don't have a point and you want to find out the point like near to that object, so you need to specify a point on pipe center line, not on end. So for that you have also the option of shift plus right click and select the near, click anywhere on the pipe body or whatever component you are using. So there are you, you have a option like a shift right click, or you have one more option like control and right click. Still it will show you those options, but try to use a shift. Sometimes control will not work. Okay. Now let's move forward with the one more option. So before that, let's take a 5 minute break. Hello.
Okay. Okay.
Yeah. Okay, let's start. So let's move forward. The next point which we will be learning about is a elevation snap. There is one more like snap called elevation snap. This is very useful when you want to connect to the vertical pipe without changing the routing plane. Like you have routed a pipe on horizontal plane and you want to connect the pipe to the uh, vertical uh, uh, run the pipe on vertical plane without changing the plane. Then you can use the elevation snap. For example, you are routing a horizontal pipe, and you want to connect to the vertical pipe that is the same elevation as you are routing. So normally your cursor would snap at to any point on the vertical pipe, right? But with the elevation snap turned on, it will snap to the exact point on the vertical pipe that matches your current elevation, right? So to turn on elevation snap during routine, you can right click and find the elevation snap ribbon option, or look in compass panel on the ribbon. It toggles. Click to the turn on. Click and to turn off. Sorry, I didn't do anything. So this is a elevation and routing option. Here you have options like or toggle elevation snap on off. Here it is given the center of pipe. COP means center of pipe. You have different options like bottom of pipe, top of pipe, and center of pipe. Also, if you want to change the snap to top left, top right, center left, center right, bottom left, bottom right, you have those options also. Now we will be taking the bottom of pipe option here, and to turn on this option you need to click on toggle option, and whenever you are routing the pipe you need to give this is the elevation which has been taken, but I want my bottom of pipe elevation should be like 25,000, and I clicked, and when I click the pipe you will see, I will show you now it has automatically changed the elevation. If I give the bottom of pipe elevation here to you, like quadrant point of this is the on a 25,000. So you can route your pipe without changing the plane just by using this elevation option. So there is one more like elevation option, like if you want to route your pipe horizontally offset, like I want to route my pipe offset 2.5 meter. So if I select, and you can see what my zero is showing, and the pipe has been routed on opposite of that. So you can see now I have taken this part, but if I want to go up and if I want to go an angle, it will show that same. And till if I want to change the elevation of my that pipe, it will automatically change the elevation, right? So this is how it works. Okay. So if you are routing the pipe, like you have given the like you have the one point which is the line, this is the line, and this is a structural line, a structural end. Sorry, this is the line, and from this line you want to run your pipe 2.5 meter on below of this line. So now I will select here the offset has been given. So I will select end point here from this point end point to this end point. You can see The pipe has taken the center of this pipe is a 2 point meter. So this is how you can route your pipe, like your pipe rack end. Your pipe rack starts from here, and your pipe rack from this point you know the distance, offset distance. Then you can do that. And also same, if I want to route my pipe on that side, I have to go from the right to left. Then it will route that pipe on opposite side. So this is the simple funda to use the route the pipe on offset distance. And also this is very useful whenever you are using the routing the pipe on uh, on side of store, or like on pipe rack, on from one pipe has been routed and the second pipe has a center. Like from this pipe I want to route my pipe offset like 300 mm, but that will be not the center of pipe, that will be uh, top top of pipe, but that top of pipe will not work here, I think. So for that, what we need to select center left. So I will route pipe from this end point to the this end point. So now it has taken the pipe on a left side because we have selected the center left. So what if I choose the top top left, left select top left. And let's go. Yeah. Now you can see my pipe has been routed beside that pipe from the center. It has taken the distance which I have wanted. Now you can see, I will show you how that works. Now you can see this is a 330 mm because I have selected this point as a 300 mm. If I show you from this quadrant point, this distance will be 300 mm. So this is how the pipe routing works. Elevation and sorry, this is elevation and routing works. It is very important pipe feature whenever you are routing your pipe on a pipe rack. Okay, it gives you option to select where your pipe should run, what elevation you want to run your pipe. Okay, so now let's move forward and let's
Yeah.
get to
Can you
know. Yeah,
explain about that where exactly we are using in pipe rack and maintain the distance between two pipes in
two
between the
pipes,
pipe rack?
but for that you need to give the offset distance first here, right? And if you are routing your pipe, like I will remove this distance here, and I will not give option. Now I want to route my pipe here. This is on zero elevation, for example, and I want to run my pipe on the elevation which is 15 meter from from this pipe. So that will not take the 15 meter from this pipe. It will take that elevation from the zero. Like your ground elevation is zero, it would automatically take the elevation zero from there. And I am routing my pipe from, come on, 15,000. And now I will on this elevation option, toggle elevation tab. You can see it has automatically routed my pipe on that elevation. I did not need to change the plane for that. If I go here and change check the elevation. What happened? Okay, let me show you one more time. Now I am in 2D plane. Okay, I want to route the pipe, but that pipe elevation should be 15 meter. So now you can see I have routed the pipe which has changed the elevation automatically. I did not need to change the plane for that. Without changing the plane, I am able to change the elevation of pipe. And the second option, which I have shown you, it is a offset. Offset like vertical offset. If you want to change the, if you are running the pipe on vertical side and you want to change the like from that vertical pipe, you want to offset your pipe on some other distance. So for that you can give the vertical offset distance like here I will give the offset distance like 500 mm. Okay, and now I will draw one line here first, and whenever I'm drawing my pipe from this end point to this end point, you can see it would be on the okay, due to plane, we are not able to route the horizontal vertical pipe. I will change that plane. You can see it is automatically routing that pipe offset from this line. See? So now I show you 530 because it has taken the center point of this pipe. But we have given the bottom of pipe. So if I change this UCS V and do the DI from this line to quadrant point of this pipe. You can see the X direction which has been shown here is a 500 mm. So if you are routing the pipe horizontally or vertically, you need to mention the offset distance here first. So from that point, it will automatically offset your pipe. Hello?
Yeah, okay.
Okay. So try to do this practice first because when you try to do these all practices, it is easy to understand. It is not much, I will say, it is not the rocket science. Okay? We use this word sometimes, but if you do the regular practice, you would be able to understand this easily. Okay, and most of the soft piping routing softwares which I have used and like CADWorks and Plant 3D, I think Plant 3D has like easy to understand in all those pipe routing softwares like E3D, SP3D, PDMS. In those all softwares, this is the software which is easy to understand and it has the interface which is also we can understand easily. Okay, but this is not like you are using this software first time and you will understand all the things. For that, you need to do the practice. Okay, so the next point which we will be learning about is uh, about the piping bends. Okay, so they if we go from the basic, like if you have gone through the pipe fittings, what are the pipe fittings we use in piping, like elbow, we use the elbow, right? It is a pipe fittings. Uh, but the bend is a different and elbow is a different. If you get the know about this because uh, I will explain the difference about what is a bend and what is a elbow. So this topic is also the confusing, because for that I will say you need to have some theoretical knowledge also, like the difference between the elbow and a bend. So now I will explain you this also. A bend is prefabricated fitting. It is manufactured in a factory, right? It comes in standard sizes like 90-degree, 45-degree, and is welded or flanged to the pipe. So it has a very specific bending radius defined by the standard, usually called as a long radius or a short radius. Long radius elbow is smoother and causes less pressure drop. A short radius elbow is more compact. So if we are routing the piping in short, minimum space, we will be using the short radius. And if you don't want to drop, like we don't want to drop pressure drop, then we will be using the smoother radius elbow. So a bend, on the other hand, is a pipe that has been bent in a field or in a pipe shop using a pipe bending machine. Instead of welding a separate fitting, you can make a straight pipe and bend it in to the required angle. This is used in a small diameter pipes, usually 2 inches and below, and also in pipe racks, where you want a smooth, continuous flow path with no weld joints, right? And also uh, for the real life examples, think of it like this: an elbow is like buying a made corner piece uh, for the water pipeline system at a home. A bend is like taking a flexible pipe and physically bending it into the angle you want. Both gives you a change in direction, but they are manufactured differently and used in a different situation. So how does Plant 3D handle this? In in AutoCAD Plant 3D, by default, when you change the direction while routing, the software adds
Peter,
elbow.
Vinod?
Hello, hello.
Yeah, sorry, by mistake I answered.
Okay, sure. Just mute your mic. Thank you. So the software adds an elbow. This is standard behavior which has been added in, I will say, programming or in spec at the time of doing the pipes, adding the pipe spec. uh, so the software picks the correct elbow from your pipe spec automatically, right? And but if you want to use a bend instead of an elbow, you need to activate the pipe bend mode. Once pipe bend mode is on, whether you change the direction while routing, the software adds a bends instead of an elbow. So let's get know about how to create a pipe bend step by step. Okay, so let me show you exactly how to create a pipe bend. So if you can follow these steps, that would be also good. So first, click on route a pipe segment. Click route pipe from home tab. Specify the start point and click the first point of your pipe route. So I have specified the first point. This is my first point, and from there my pipe is start. So and uh, click the first point of your pipe route before changing the direction. look at the ribbon tab here in the home tab. Find the you will see part insertion here, and in part insertion panel you will see button called toggle pipe bends, which is this is this is the toggle pipe bends option. So click on to turn on the pipe bend mode. Now I have on this option. Now at the end of the pipe segment, click the continuation grip. I have given added a uh, like I'm routing the pipe already, so I have given the in the pipe first pipe, and I'm I'm clicking on continuation option here. So when I click on continuation arrow, the routing continues from that point. So if you do not want the angle to snap to compass increment, you can go to the compass panel and click toggle snap, like toggle compass this. So you can off this option, and my F8 option is also on. I will off that option. So now click the uh, drawing to specify the next point. The software will automatically place that pipe bend at the change of direction. So let me, if it should be on here, I'm taking the 90-degree here. So now press enter after finishing, and you can see it has added the pipe bend automatically because it is selecting that pipe um, uh, and bend in one, like it is whole one part. If I show you the normal routing, sorry, this pipe bend option is off, and if I route the pipe, for example, you can see it is showing elbow, selecting the elbow differently and bend differently. But when I selecting this, which has been added a bend, it is now it is showing the pipe bend, which pipe configuration. It is not showing us the description of elbow because this is not the elbow. This is the pipe which has been bent. Okay. So this is how you can add the pipe bends in your modeling. If you are not using the uh, like elbows in your piping, so it is also very useful. So try to see how elbows are added and how bends are works in differently. Okay. So now let's move forward to uh, one more option, which is cut back elbows and roll elbows. So they this is now there is a more advanced topic related to bends. This is a more advanced actually because
So
we have added
where we can use pipe bends means toggle pipe bends where the continuous line connecting one equipment to another equipment. We then we have to identify the line. It is a single line. I think. That area we can use.
I, actually when you are use when you can use the bends means like you don't want to add a welding to your piping, right? You want to bend the pipe and you can bend the pipe and add your piping to that like I'm bending my pipe to 90-degree here without the adding the welding. So this is the option which will be giving you minimize your welding. You want to add a whole pipe, not the elbows or any fittings. So you can use the bends at that time. But if you are using the elbows in your piping, so at that time you will be not using the pipe bends option. Okay. So mainly where the pipe bends can be used, I will say, um, you want the pipes which are not sorry, which needs the radius more than your standard elbow. Like you want to use a 5D elbow, a 5D bend there. So 5D bend you will not see in your standard because it is long radius or a short radius. So at that time, what you will be doing, you will be using this pipe bends option. But when you are using this pipe bends, it is showing only the standard bend here. Like it is only showing the 90-degree, but this is not a 5D elbow. If I want to show 5D elbow, for that, there is different option. Like you need to draw the circle and give the 5D radius of your pipe. Like time, your diameter of pipe is 100, so the 5D radius will be your 500 mm. So that you need to give the radius of 500 mm to that elbow, and then it will draw that elbow by using this line to pipe option. You can add that elbow. Let me show you. I am drawing the one circle with the radius of 500 mm here. Okay. So what I will be doing, this that elbow will be 90-degree, right? So I will do one thing here. Like I will rotate this and copy. Okay. And I will trim this part here. Okay. Now what I want to do, I want to make this as a elbow. So I will select this line and click line to elbow. Still it is showing me it is not showing me the elbow here, right? Correct? Because it does not have given the radius. It is taking it as a elbow, like straight line. So for that you have bends option. Now you can see by using on by like I have on this toggle pipe option, bend option, and clicked on line to pipe, and it has created. So this is my like this is not the uh, bend which I am using. Like this is not the bend elbow which I standard which is standard. This is the bend which has been created by bending that pipe. So this is how you can create the different types of bends, and it will connect your whole piping in a one component. Not it will not show the different pipes. So if you want to add a elbow here, that elbow will be also the bend because this bend option is on. But if I want to add a normal elbow here, I need to off that option, and then I will be able to add that elbow here. Okay. Hello.
Yeah,
So the bend is mainly you are bending the that pipe, not you are using the standard elbow. If you have seen that in your fundamental classes also, the bend is different than elbows because it has more radius and all the things. Okay, so let's move forward. Let's move more advanced part in this bends, which is cutback elbows, right? So cutback elbows and roll elbows, this is used when you are routing a pipe on a slope, like on a slope or on a different angle. Like your elbow angle is you want to take it differently. It will be not a standard. So when you route a pipe at the same elevation, The elbows will work normally, but sometimes in plant you need a pipe to have a slight slope. Okay, for drainage or for a gravity flow, when you apply a slope to a pipe, the elbows at the end need to be modified. So plant ready can do this automatically. Mainly a cutback elbow is a elbow where one end is slightly its one end is cut slightly to achieve the slope, and a roll elbow is a elbow that is rotated to accommodate a slope. Okay, so let me show you one option here to you all. This is I'm changing the UCS here and taking the size 100 and routing the pipe like from here, and I want to change the I want my pipe to not on 90 degree. I want little bit slope here. So I will on this cut back elbow option, or uh, a cut mainly a cut back elbow is where one end is slightly cut, right? So in plant ready during routing, when you are specify next point from yeah, when it is ask you to for the next point, so uh, you can type a cut back elbow, which is has been given here. You can select from here also, or you can type C and enter. And before adding the cutback elbow, um, you need to turn off your off ortho. So then you will be able to add your cutback elbow on that slope. So mainly you can see that elbow has been cutted because it is not 90-degree now. It has changed some angle. The elbow angle has been changed. So this is how a cutback elbow is achieved. It will be help you to achieve the slope. So there is one more option which is a roll elbow. You can select click R enter, and you can roll this elbow on a different angle also, not only on a specific angle. You would be able to roll and also add a slope. So both things you can achieve by using this cutback elbow option, right? So this is useful when you are like you don't have a like elevation of your no, you don't know the slope. What is the slope you want to route? But you have this cutback elbow option, and you know the end connection is there. Like I will say I know the second elevation will be this is I will copy this line here. This is my second elevation where I want to cut my pipe, and it would be an L like angle, right? So I'm specifying my taking the center line here, and now you can see it is taking the straight because we have added some, but I want to give the elbow little bit slope, and I want to on F. You can see it would add that elbow in a cutback manner. So you can see here the slope which I have given. So this is how you can add different types of slope. And if you already know the slope, so you like you if your compass is on and you are routing your pipe, it will when you are using the cutback elbow, it will show you the angle also. So if your compass is on. right? For that, your compass need to be on. If that is off, the compass is not on, then that would be not possible. Okay. Now let's move forward with the next part is our continuation grip. So what are the grips in plant ready starting from like basic? Sorry. So now we talk about the something called grips. For those of you who have used regular AutoCAD, you know what when you click on object, the small square boxes appear. Those are grips. So you can use them to move, stretch, or modify the object. In AutoCAD Plant 3D, grips work similarly, but they have a special functions specific to piping. When you click on pipe or fitting, you will see several like several different colored grips appeared. So let me explain each one. So the continuation grips like arrow plus. So you can see if I select this pipe, you can see the continuation grip like this plus this arrow, right? So these are starts routing new pipe from that port. Uh, so this plus sign will start uh, the pipe routing from that port, and the plus sign which has been there is square at the uh, end of this square, which is a move grip also. So you can move your pipe here from move part option by using move part option. Like I am routing one pipe here, I will show you. So if this square I'm clicked, I can move my part. This is a move part option, and so the branch continuation grip is there, which is this. Yeah,
Uh, one now. So you said now, so we can convert when we draw the line, we can convert into that pipe, right? So when
yeah.
we draw the line, so
Hmm.
that the plane change option is not available, huh?
Actually, when you are drawing your line, like I'm drawing a single line here,
Mm,
right?
mm.
I will on my F8. Sorry, not F9, F8. I don't want this. So I'm drawing my line in some angles, which is already it is going up, down, side, straight, forward, right? So I'm not changing any plane here. I'm just drawing my line in 3D view. Okay. So if you draw your line in only like a plane view, X and Y coordinate, then it would only draw you line on straight because it is a simple AutoCAD line which I'm drawing. I'm not drawing any plan using any plan 3D has given any different option for the line. It is not. It is the only simple line which we draw in AutoCAD.
The
So if you want to
compass,
give the angle, if you,
the compass option also is the
yeah,
same.
if you want to use no, the compass will also not work for your line
Mm,
because compass we are using the compass for our pipe, right?
mm. So that will not.
So
Okay.
line is not the pipe.
Mm,
Yeah.
okay.
As we have spoke, the intelligent part, it will work only for the intelligent part, not for the line.
Mm.
So you can draw like a polyline or a simple line. But when you are drawing a single line, try to do one thing. Select all the lines in one go. then it would be able to add all the elbows. Okay. Or if I do like select the line, like this line and this line. Okay, I have selected this line and done line to pipe, and again I selected this line to pipe. It will not connect the add the elbow automatically. So for that you need to like give the select the all the lines. But if this line was polyline, then that would be I only need to select one times, and it would have selected all the routing, right?
Oh, so one more thing. So suppose if example, so I've
Mm.
deleted any elbows, okay,
Mm.
any bends, okay. So later on,
Okay.
I want to re-add that elbow, okay. So
Okay.
so we have to select the pipe again, like the plus mark, or otherwise we can select both the lines and automatically there is any option that can
Okay, so
join.
when you convert this line to pipe, right?
Mhm.
So
Mhm.
it has added a elbow. But as I
Mhm.
shown you that but when you convert this part, you need to know one thing that this line would be gone. This line would be not there. This would be a pipe.
Yeah, that is fine. So
Yeah.
if I deleted the elbow, can you delete that elbow?
Okay, just a moment. I will click create line to pipe. Yeah, and I
Okay.
click deleted
Ah,
this elbow. Okay.
yes.
Yeah.
Now I want to re-add this elbow. So
Okay.
should I
So you
click
want to
again the plus mark? Yeah.
yeah, you can click on plus mark and select the node point of the pipe which you are connecting. It will
Mm,
automatically add the elbow there. But it would add
mm.
that elbow when the spec has been added a correct elbow in your pipe spec, these specs. It would not take the elbow if that is not added or it has been not given the priority.
This is the only method, like so to add the elbows, like
No, no,
giving the
no, no.
plus mark
There
and
are different methods. Like you can take the like I shown you how to take the pipe like 5 ways. You can take
mm,
different fittings in those ways. Like you can you have this tool palette open, and in these tool palettes you have different components like flange. I have taken the flange, and now I'm adding that flange here, but this is not possible connection because the flange is socket weld and elbow is pipe is butt weld. So now I'm taking the weld neck flange and adding that flange here. You can see the flange has been added automatically. So you
uh,
can take the
and
fittings from here, and also the
uh,
walls. Yeah, the
that
walls
that
also
I
you can take
understood.
from. Yeah.
What I was asking, so now
Mm,
so you re-added the elbows, right? So that is the
yeah.
only method to re-add the elbows, or any other method like to re-add the method, so elbows, like can we connect,
Yeah.
can we join, so like join connections
I.
or anything as
Hmm,
such common.
yeah. Like there is one more thing. I know my pipe has to be run only till here. Okay.
Mm.
Giving this end point and taking this point to this end point. But this is not adding the elbow. Sometimes what happens, I don't know, it is happening in new version, but in old version there was like the options that if I take this like node point here, it would have added the elbow directly,
Automatically.
but that is
Mm.
not happening here. Okay, so for
Okay,
that I
okay,
have only one option, which is I need to add a elbow by clicking on this plus sign.
okay, okay, okay.
Yeah.
Sure.
Yeah.
Yes.
Yeah,
So,
yeah, yeah.
I
Sometimes you are using UCS command to change the view top to like a front view.
yeah,
How can you? How are you doing?
why I am doing that? Because I if I go and this plane is showing me X and Z Z axis, right? So sometimes I would be not able to route my pipe straight, or like in an angle, straight. I don't know. Okay, this is a compass has been on. So I'm taking the UCS W here, and I'm adding the pipe. Okay, it is automatically changing to X and Y when I'm adding that pipe. But I want UCS to be W. Actually, what I'm doing, I'm just giving the command to it. As I have mentioned this also, UCS is your X and Y coordinates and axis which you are using. So I want my X and Y coordinate as per the view. So whatever view, like I have taken this as a my view, right view. I want my X and Y coordinate and this on this axis. Okay. So what I will do, I will give UCS command, and then I will type V, which means view. So it will take the view as a X and Y coordinate. Hello.
Means whatever the side we want to view as a
Yeah.
top or
Yeah.
whatever the next
You
is
can
the
you,
coordinate.
you can you can use this UCS V command to change the axis. Like it would not show you the Z axis, but when you are finished with this, you need to go click on this unnamed option and select WCS, and then change the plane. Why I am saying this? If you do the unnamed, like, yeah, I will show you again. UCSV, I am selecting UCSV here, right? This is my X and Y coordinate. And when I will change the uh, like side, I have changed the side, but you can see the my view cube is also rotated, and this plane has been also rotated. So this, if this happens, uh, don't mainly it is not a big issue. Just what you need to do, you need to change this unnamed option, or if it is you are unable to click on screen, give the command again UCS, and we give the command of UCS, and then we selected V. On the place of V, select the command like a W. Okay, and click enter. So it would be automatically the word coordinate system, and just you need to click on top view, and it will automatically come to the normal space. And one more thing, this is a home tab, which is a home option which has shown here or here. It should be a parallel always. If you are selecting the like perpendicular, sorry, perspective, uh, I think that would not much affect, but always select the parallel option. Okay. Sometimes if you have selected the perspective, it like it would make you difficult to run your piping also. Sometimes that issues sometimes we face. So it would be default parallel. So that would be a good. Okay. Now I was explaining you about the grips. So the in grips there is option which is like plus sign here. This is the plus sign which has been shown. It is used to create the branch. If I want to take the branch from this pipe, I can take branch. So it has added automatically T, because that has been given in a specs. Okay. So these are the continuation grips. Also, there is one more grip which is rotation, but it would not work for the your elbow. Sorry, pipe. I will show you how rotation grips work. If you show this rotate part option, this is called a rotation grip, where you can rotate your elbow on a different direction. Sorry, T. Also, if you have added a elbow here, and after that elbow you don't have added any pipe, so you can rotate this elbow also on a different angle, like 90-degree angles. Okay, and also you can give the rotation angle also 45-degree. I have given the 45-degree, so it had rotated my elbow on 45-degree. Also for the T I can do that. So 45-degree, it would add a 45-degree automatically. Also the walls, I can do same for the walls also. The rotation option is there, for continuation grips has been given to the walls. So those things already given in Plan 3D whenever you are adding the component to in your PySpec. Okay. So now we are learning about a grip. So let's move to the continuation grips. The it is mainly the hero of pipe routing. So the continuation grips is the most important grip in pipe routing. This is the arrow that appears at the open end of a pipe, and end that is not yet connected to anything. It is your continue from here button. Okay. So when you click the continuation grip, Plant 3D automatically starts the plant pipe command, which you can see here, and from that exact point in the right direction with the same pipe size and spec as the existing pipe. You do not have to type any command. You do not have to specify the start point. Just click the arrow and start clicking where you want the pipe to go. So for real life, a real example, imagine you are building a train track. You have laid some track already. The continuation grip is like the green light at the end of the existing track that says uh, extend the track from here. You click that light and just keep laying more track in that direction you want. So this is how continuation grip works. So now using the continuation grip to add elbow, we have added a elbow here. But now let me show you one more option which we have already discussed. But let's go again because we are learning about continuation grip here. So that's why. Okay. So now using the continuation grip, how to add a elbow. So here is very useful trick. If you click the continuation grip at the end, at the open port of 5, meaning at the end of 5 that is connected to not connected to anything, sorry. So and you click in a different direction, the software automatically adds the elbow. Yes, you did not have to manually place the elbow. The software does it for you. So this is how. And also one more point which I have told you, that you need to select the node point of this, and it would add a elbow and directly to that. This is the one more option to add a elbow. So for example, you have a pipe going in each direction, you click the continuation grip at the each direction. So like this, and I click taken the continuation on each direction, it would add. Then I click on north direction here. So the software adds 90-degree elbow. Uh, so the software adds a 90-degree elbow at the corner and starts routing the pipe to the north. So is it beautiful, right? So the next continuation, which branch continuation grip. to create a T. So if I want to take the branch from this pipe, I need to click on the middle plus sign of this. This is called a continuation grip. And if I'm selecting uh, the pipe which is on the front side, I can add it would add automatically T here also. So because the pipe spec has added the same T's and so for the same sizes. So this is how we can add take the branch from a pipe. So if I want to take one more branch from here, I can do that. Okay. So this is how we can take the branch from the by using this continuation grip, branch continuation grip. So the next is stubbing mode, which is routing without a branch fitting. So for that, most sometimes what you need to do to you want to create a branch connection without a T or weld OLED fittings. This is called a stubbing. In stubbing connection, the branch pipe is simply welded directly to the main pipe header. No fitting is used. So this is common in utility lines and in situation like where a fitting is not available in the spec. In plant ready, when you are using the continuation group to branch, you can type stub in command line and press enter to toggle. Okay, so this is how the continue like we click on plus. So I'm taking the stub in, right? So you need to mention the size for that. I'm taking the 50 size and click enter. And if I am adding the 50, it is automatically taking the T. So for that, what you need to do, you need to click on continuation grip and give the stub in option. And for that, mention the smaller size, which it will add as a stub in. So stub in means the part which has been taken from the like welded from the inside of pipe thickness. So in plant ready, when you are using the continuation grip to create branch, you can type stub in the command line and press enter to toggle in stub in mode. But when stub in is on, the software creates the branch without placing the T, as you can see. Okay. So let's take a 10 to 15 minutes break and then start again. Okay.
I think you are muted. Your voice not.
Hello, hello.
Yeah, yeah.
Yeah, okay. So I was explaining like what is a part substitution, like substituting a part. So I was explaining like what is part substitution and why do we need it. Okay. So we now come with like very practical feature, part substitution. Let me first explain why this feature exists and why it is so useful. So in real life design, like what I have shown you here, the pipe, like so in real life design, you often start with one type of fitting, like we can say 90-degree long radius elbow, and later realize uh, that a different type of fitting would be better. Maybe the engineer says use a short radius elbow. So here, because there is not enough space, or maybe you routed the pipe with a standard elbow and they realize spec actually requires a special elbow. So without a substitution feature, uh, what would you have to do? You would have to delete the existing elbow, reroute the pipe, and place the new elbow. This is a lot of work, especially if the pipe has many fittings. With the substitution grip, you can simply select the fitting you want to replace, click the substitution grip. Okay. So this is the substitution grip. This is a substitute part of which is called a substitution grip. And you with the substitution grip, you can simply select the fitting you want to replace, click the substitution grip, and so choose the replacement from a list. So we have a in specs mainly. Only the long radius elbow has been available, and other option is pipe bend. So we want to convert it pipe bend. So now I am selecting it as a pipe bend, and if I go, so it will show me the pipe, not the elbow. So if I show you the elbow description, elbow has a different description. This is the elbow description, and pipe bend has a this different description. So if they in this fitting in our spec, where we don't have a available like short radius elbow, that's why it is not showing me the option of different types of fittings. Okay, types of elbows. But if that was available in pipe spec, it would have shown you these different elbow types also. So uh, for using the substitution grip, if we go step by step, you need to select first the fitting which you want to replace, and then click on substitution grip, and from the substitute you it will open the drop down uh, so drop down list or selection dialog will appear, and uh, you have all the compatible parts from your spec pipe spec that can replace the current fitting. will be available under that drop down list. And you need to select the part you want to use as a replacement. And as for example, I told you that 90-degree long radius elbow you are using, the list might show 90-degree long radius elbow current, 90-degree short radius elbow, 45-degree elbow. And let me show you one more option. I will delete this pipe and I will click on this list here. Sorry, substitution gap. Now it is showing me the 45-degree elbow also. So you can change that and it will automatically change that elbow. So this is how you can use the substitution grip. It is very useful whenever you are using this. You have added a part which you don't wanted to add or you want to change. Okay. So there are
Okay, how to
some,
add actually that 90 degrees bend is that before that one top of the bend one line also connected. So
yeah,
in
yeah.
between that
Actually,
between
if
of that
my
bend,
my
how to
if
add it?
yeah, yeah, if my you will be not able to add a 45-degree elbow because if you have already shown the connection here. Okay. Why I deleted this pipe? Because I wanted to show you that in this selection list you have one more elbow which is 45 degree, right? But if my line was already here routed, right? So I would not be able to add that elbow on 45 degree, because here I have already given it constraint, like it is connected here and it is connected here. So you would be not able to show the 45-degree elbow, because that's why it is not showing me the option. When it is connected to both the pipes, it is not showing me the option of 45-degree elbows. But if I delete one of this connection like this pipe, so then it would be showing me the option of 45-degree elbow, because 45 degree has been added in our spec already. You can see. Let me show you one more this substitution option. I'm adding the gate wall here. Okay. And after adding gate wall, I am selecting the wall and adding the substitution option. So when I click on that substitution part option, you can see these all the types of walls which are available for that size, which is DN200, is shown here. You can see. So the all the parts available will be you will be able to see under that list. So this is how means if I want to change this to the wall long radius, I can change. If I want to show the butterfly wall here, I can show the butterfly wall here like this. Also, if I want to show the different type of wall, I will, like I want to show the check wall, sink type check wall, or I want to show the check wall, this check wall which is butt weld. And also if I want to show the plug wall, short radius or short pattern which is flange weld, you can show those all the change by using the selection substitution part. Okay. And for the elbow, when you want to add a 45-degree elbow, you need to have a one end open. Okay. If you want to use the substitution part option, because if it is not open, then it would be only showing you option of 90 degree, because it has already given the constraint, and constraint means it is already connected to two parts. So how if you think like actual practically, if your piping has been already connected, right? And you want to add this pipe is has been added on 90 degree, and this is coming this angle is 90 degree, and the you want to add a 45-degree elbow here, that is possible.
No, not possible.
Oh, so software is also work like that. It takes the real life example for that. It is not like it will take anything you want. It has some rules already given, which it would be easing, and we use those rules for a piping also, in piping. So it is created for the piping. So that's why uh, this for the elbow part it is different. So for the T also, I will show you one more option for the T. Like if this T has been added and if I click on substitute part option, it would only show me the option of it would show me the branch size changes, the sizes which I can change of branch. Like I can take the DN80, but when taken the DN80, it is showing that this bigger size has been connected. So now it is taken the correct, because when you have connected already, it shows you error. But if it was not connected to this pipe, and if I go to the change the pipe branch size, you can change, and it will not show you any error because it is not connected to any pipe. Means it does not have given any constraint. Okay. So
Actually, what my doubt is, in
yeah,
that bend, in that phase of bend, how can we
yeah.
add a T? Means if you want to take another horizontal,
No, no.
how can we
Actually,
add?
when you want to add it, it would be you will be not able to add a T here, because this bend is different part which you have added. So if you have created seen the pipe spec document or any document, you should have know that elbow is different fitting and T is different fitting, and both the fittings which you are using has a different purpose or different application, right? Elbow is to change the direction, T is for the taking the branch, right? These are the basic fundamentals of fittings. So when I have added the elbow, it would not show me the option of T. Okay. Because if it is showing me the T option, then that yeah, mainly uh, it is not bend. Means there is bend, means there will be a no T, and if there is a T, that there will be a no bend or elbow. Means they are both has a different. So if you want to add a T here, then you need to do one thing. You need to route this piping till here and extend this pipe till here. It would sorry. Now it you need to click on plus sign and click pipe. It would automatically add a T. So this is how you can add a new T. Okay. But if you have given the elbow, you would be not able to add a T on the place of elbow. Okay. And one more thing is there, which you are not able to add by using the substitute option, but there is this plus sign which has given, which is continuation, and you would be able to add a T by using that continuation option without deleting that elbow. Okay. These are the different option which has been given to adding the fittings. Okay.
You have added T, right? One more time add.
Hello.
Yeah, you have added one T, right?
Yeah.
Oh, can you show me how did you add?
Okay. Now, I didn't use this substitute option actually. I used the continuation grip. Okay. We learn about the continuation grip first, then we learn about the substitution part. Okay. So continuation grips means this plus sign which is showing here, right? And this elbow has been only this 90-degree direction for 90-degree direction. But this plus sign is showing, if I click on this plus sign, you would be able to add a T there. You can see it is adding the T automatically when I click
Yeah,
on
yeah.
continuation option. So some of the important rules for the pop part substitution, which I want to say or explain to you, that the rule number one is the same size. The replacement part, which must be the same nominal size as the original size. So you cannot change the like substitute a 4-inch elbow with the 6-inch elbow using this substitution part grip. Okay. And the second rule is compatible end. The connection type, which the connection type must be compatible. For example, a butt well elbow can be substituted with the another butt well fitting. Socket well fitting cannot be substituted with a flange fitting using this substitution grip. Okay. And the third rule is part must be in a pipe spec, which the part which you are using, it should be added in pipe spec. The replacement of the part must be exist in your current pipe spec. Means we are using the SS150, so the replacement part should be available in these specs. If it is not available, then it would be not if the spec does not have a short radius elbow, you cannot substitute it in even through the physical geometry might work. Means it you would be not able to change that. So the fourth rule is path angle must match, like for the bends elbows specifically. If you have a 90-degree elbow and want to substitute with the bend must also be a 90-degree bend, and the path angle must be the same. Also, there is one more important note, which is you can write it down or somewhere for the understanding. If a custom elbow or pipe bend is not showing up in substitution list, uh, uh, check the spec editor. So the path angle of the custom part must exactly match the path angle of the part you are trying to replace. So this is the common issue in project with the custom catalog items, like different types of fitting, different types of uh, I will say different standards. So those are the fittings. So sometimes we face this kind of issue. Uh, but for the spec editor, I think tomorrow we will be learning about that. So don't worry about that. We're taking one by one all the details about that. So now we are in last part of today's session. Mainly there are some commands which I want to tell you. Uh, so commands which you can use by using the keyboard. It's like mainly I know many of you might think that we will use the ribbon buttons. Why do we need commands? Like so, let me tell you why. In professional plant design work, you are working with hundreds of pipes, thousands of fittings. Speed matters. Using ribbon buttons require you to move your mouse to the ribbon, uh, click, come back to the drawing, click again. If you know the keyboard commands, you can type them directly and stay focused on your drawing. So, experienced plant 3D users type commands without even looking at the ribbon, right? Because they have done that practice of using that how come using those commands. So the main pipe routing command which we have already discussed is the plant pipe add, right? We have discussed at the start of our session that this how this command we can work, we can use. So this is the primary command for routing piping and inserting piping components in plant 3D. So you can say this is the king of all pipe routing commands. Whenever you click route pipe on the ribbon, this is the command that runs behind the scenes. Okay. So you can also type it directly when plant pipe add is running. You are the specify start point prompt, which is here. You can see it is asking me for the specify start point, or it is asking me for the size specification, stubin elevation, or routing offset. Those are the options which has been there. So size means the pipe size. If I click yes for for the size, yes is the shortcut, and for the specification, SP is a shortcut which will be telling me which specification you need to you want to use. So stubin has a EST is a uh, stubin shortcut command. So elevation, for the elevation it is E, and for the routing offset routing it is O. So shortcut command is O. So also after adding the pipe, like if I want to add a pipe bend, so for the bend it is command is B. Also if you want to see the pipe fittings, for the fitting F is a shortcut command. Cut for the cutback elbow, the command is C. Roll elbow R. Elevation E. Routing offset O. Base component CO, and undo U. And for the pipe fitting F. So if I click on pipe fitting, it will take me to the spec viewer where I can select the fittings according to my requirement. Like I want to select the T, I can select the T and place that T here. So this is how we can add fittings different parts by using these commands. Okay. So also there are some other commands which you can write it down, or you need to see again what command, why we are using, try to use those commands at the time of using the plant ready. Like the second command which I am telling you is a plant spec viewer. So the mainly plant spec viewer is it shows all the components in your specs which has been added. So from here you can add those components. It is same like a tool palette. We have a tool palette also, and we have a spec viewer. So the third command is the plan show all. So means if I have hide this here, if you see, if I hide selected components and give the command plant show all, then it would automatically show all those components. So there is one more like plant weld add command, which is adds a weld marker to pipe joint used for tracking weld section. Like I will show you how that works. Plant weld add. So now I want to add a weld here and click enter. Can see it it would add again. I will be running. So if you see, select the pipe segment to add a weld, or type auto placement distance. So From here, I'm giving 300 mm. So it would add that weld point automatically. Now it has divided that pipe in two parts. So it would divide the pipe, means it would not only divide, it would add a weld point to that pipe. Okay. So the fourth, like fifth command is a plant pipe supports, which is used to add a plant pipe supports add, which is used to add a supports in your piping. So if you I want to add a U clamp to my pipe, so I just need to select the U clamp from there. For that you have this pipe support option is there also. So from here you can take that pipe like create, or you have this pipe support spec which is already there in your plant 3D tool palette. So you can add that support from here also. Sometimes for the adding the supports, I will say don't use the command, use this tool palette, which will help you to add the add the supports easily. Okay. So also there is one more command like plant PCF export. So this PCF I will explain you later, because how this works I will tell you all those things. And sixth is the plant quick ISO, which we will be learning about later on. So so one more thing, whenever you are using different option, it in command bar you will get those command written here. So try to do one thing like uh, write it down or memorize. If you do the practice again and again, you would be able to uh, understand and use those commands by using this regularly. You would be able to use that effectively. So now actually we have not much time, so I just want to give you quick scenario. If you can do that would be a good, like uh you can do the this pipe routing, whatever we have options seen today, you can use those options and try to route the piping, uh, and try to do the like uh, mainly what you need to try to do the suction discharge piping. If you can do, you have already uh, use you have learned about the fundamental classes already. We have created one PNID in our plant 3D practice, so use that for your reference. And for today, before wrapping up, I just want to explain what we have learned today. So we have already extended our time, but I will take not much time to wrap up about the things. So we started with basics of piping in plant 3D. What is it? How pipe spec works? How to start routing? Then we learn about the compass, that very helpful circular tool that snaps you pipe to standard angles. Then we understand the different elbows and bends and how to create the pipe bends. We then explore the continuation grip, uh, like both for extending a pipe and for creating the branches. Then we learned a powerful substitution grip for replacing the fittings without rerouting. Uh, and after that, and finally, we covered all the important commands, and that's what we have learned. If we had a time, we would have tried to do one practical task, but that is not possible right now. But you can try on your own because we have a PNID already created, which you can use for a reference for your suction discharge piping. And so these all the things which we have learned in these 3 hours. Uh, Mainly this would have taken the most of the students to understand. This would take 1 day or 2 day, but in pipe routing, so but today whatever I have covered up, if you try to repeat those things, you would be able to understand the plant really better. So and one more thing I will say, you are already ahead of many beginners who takes weeks to get this far. So I think we are progressing in a good way. So as I have tell you, try to do the practice. So today's session, whatever we have learned, in tomorrow we would have a session where we will would be going like going through the spec creation, catalog, and all those things, so we can understand better, and that would be very helpful to understand, mainly if you have understand all the parts which I have told you today. And I think in tomorrow's session, if we try to if we learn about today's session all the things, then it is easy to understand the tomorrow's session. So if you have any question, you can ask. uh, and mainly
Yeah,
I
actually,
say,
while selecting that a root pipe is or command, that option is there, right? In that we are selecting SS 150, SS 300, SS 600. Those are
yeah,
classes, right? Means of schedules would be
yeah,
like
those
that.
are the classes, but no, not a classes. Mainly the spec has been given the name. It is a name which has been given to spec. It is class, mainly it is mentioning the material and class of that flange which we are using under that spec, which is 150. You can see the flange classes are 150, right? But if you go SS 300, you can see here you will be showing the flanges which are all the 300 class, and also the walls which are flanged would always all will be 300 classes. So you can create the spec as per your requirement. Like you want to create the spec as per the schedule, or you want to create the spec as per the classes. So you can create whatever you is easy to you to understand. Okay.
Yeah, okay.
Uh, Tomorrow we will try to create one spec which would be
Sure.
very useful to understand to you guys. So, all right. I think there are no more questions.
Yeah,
Uh,
yeah.
Thank you for your attention today. Where it is a great class. I enjoy this kind of things to teach. So try to spend more time in plant ready. The more comfortable you become, so it would be good for you. So see you in tomorrow's lecture. Take care and good luck with your practice.
Oh,
Okay.
your name, I forgot your name.
Hello.
Yeah, your name, I forgot your name.
It's Bhushan.
Thank you.
Thank welcome.